tech fan to another filament dryer testing video. This is Sunlu Filadryer E2. The filament dryer which can reach the temperatures up to 110 degrees Celsius, but it can also be used for the annealing too, not only for the drying. Now it is not in a box anymore because together with the Geek Detour we unboxed this in the live stream, and this box is sent to me by the Sunlu in exchange for the review. I'm not paid to do this video and I got this object for free, but this is actually a prototype, and you can see here on the box they used some sticker, and I even got the email with two things which are changed in the mass production compared to this version. So as I mentioned, this E2 is designed to dry engineering materials, E properly for the engineering, and 2 I think it is for the 2 spools. But be careful because it is not for any filament. Actually, the previous version, the S4, is great for almost every filament. PLA, PETG, ABS, ASA, because you don't want to dry these filaments on 110 degrees Celsius. So this is only for those special filaments. I already tested on this channel several, like PPA-CF, PPA-CF and similar. So also you have to be careful and check what is the maximum temperature of the spool, because probably most of the spools cannot survive these kind of temperatures. Few specifications from the website. It has 500 watts PTC heater, and it can heat up the air inside to 70 degrees Celsius only in 30 minutes. It has the temperature and humidity sensor, and it is not so obvious because some filament dryers don't have these sensors. And it is sealed for better thermal isolation, and it has double valve, so even if inside we have 110 degrees Celsius, we will not burn our hand if we touch the valve outside. The maximum spool size is 250 mm in diameter by 153 mm, or it can accept 2 regular 1 kg spools. So what will I test? Well, things I'm curious about mostly. First I want to see how fast it will heat up to 110 degrees Celsius and if it will reach these temperatures. And the other is that if I set lower temperatures, 70 or 90 degrees Celsius, whatever, for annealing or for drying, I want to see how accurate is it, because for example, if you want to dry the PLA, you set the temperature to 55 or 60 degrees Celsius maximum, and you don't want the temperature to go higher because you can damage the filament. I forgot to mention, together with the filament dryer, I got these 4 spools. These 3 are nylons and this is PPA-ABS. And especially the nylon can really benefit on drying on these high temperatures, but also from the annealing. But you know me, they will be tested in a separate video. One video for 3 nylons and one for the PPA-ABS. Since I don't have unboxing in this video, very quickly what was in the box. The user manual with recommended annealing and drying temperatures. Some Teflon tubes, and this is the tray where we can place the objects for the annealing. This is the front side of the filament dryer with the screen. This is not really touch screen, but it has only touch buttons on it. And the doors are magnetic, and I can see very nice sealing line here. On the side information, this is E2 and this is 220 volt version. This is the back side with the main switch, and here goes the AC power cable. Exits for the filaments, we have 4 on the top and 2 on each side. And for better heating, for example for annealing, we can close these openings. This is how it looks from inside. I believe that here the hot air comes in and it circulates in this direction. This is the space for the desiccant, and I believe that this is the humidity and the temperature sensor. And there are some rollers on the ball bearings, so we have the smoother rotating of the filament. I'm not sure if it is visible on the screen too, but this is one of those magnets, and there is the sealing line, some kind of a rubber, and this is double wall, so it has really nice good thermal insulation. For example, if you want to use it for the drying, first we have to check what is the maximum temperature for the filament, but also it is important to check what is the maximum for the spool, in this case for example 90 degrees Celsius. It could be a little bit smoother, not the best ball bearings. But if you want to do the annealing, we can use this tray and place it somewhere here. And we can place the objects on the top of this tray, something like this. Now why is this 110 degrees Celsius maximum drying temperature important for some materials? Well, I have this video, well actually it was not only the video but the whole research on our department, where we measured if we can dry the nylon on 70 degrees Celsius, and we did actually the experiment on 70, 95 and 120 degrees Celsius. And the conclusion was actually, if we want to dry the nylon at 70 degrees Celsius, let's say which was stored outside, I don't know, maybe a month, in our case it was in the water, and it absorbs a lot of moisture. In that case, we need more than a week to dry it completely to the state which we can use for the printing. On 90 degrees Celsius, I don't remember correctly, but it was, let's say, 1 day or something like that. And on 120 degrees Celsius, this can be done in 3 or 4 hours. So the temperature is extremely important, and we can reduce significantly this drying time, drying on 110 degrees Celsius. And I really don't recommend you to watch that video because it is too boring for most of the users. It looks like it was too scientific, and I can see in the statistics that most of them skip that boring part. Soon I will turn it on and I will show you the display. Now there is one thing I'm really missing from this filament dryer, and that's the possibility to rotate the spool during the drying. It will result more equal drying of the filament. Theoretically the hot air circulates inside, but I know that probably it is much warmer when it comes out from the heater, and it is much colder when it goes to the other side. Now rotating of the spool would be great. Yes, we can do it manually every half hour, just open it and rotate it. And I'm doing this with the old filament dryers, but here we are talking about 110 degrees Celsius inside, so be very careful because you may burn your hands. So if you want to do this manually, use some gloves or something like that. Let's turn it on and then I will measure the noise. From half meter distance, approximately 51 decibels, and if I open it, it jumps to 60 decibels approximately. On screen we can see the set and current temperatures. These are the preset values, in this case for the PLA, relative humidity, and these are modes. One is for the drying and 2 is for the annealing. Countdown time, and these are those touch buttons. With the set we can change which value to blink. Now I can change between Celsius and Fahrenheit. PLA, this is the preset value. For example, if I want to dry PETG, I would change 50 degrees Celsius, the default value is too low, I think. TPU, okay. Countdown time, desired relative humidity, and these are the modes. So in mode 2, that's for the annealing. Let's say what preset values we have. The polycarbonate is 1 on 90 degrees Celsius, and the PA or polyamide, it's also 90 degrees Celsius. Let's go back to the drying mode. When I turn it off, it needs some time to turn off the fans because it wants to be cooled down first. Since I'm not really sure that my Arduino sensor will survive this temperature, I will use this cooking thermometer. For the drying temperature, this will be its location, so I will measure the input temperature of the air, because this is what I'm curious about. If I set the temperature to 110 degrees Celsius, what is the maximum temperature which will actually touch the filament? For the annealing test, I will place the sensor on this tray because here where those objects will be located. And in both cases, I will just set the timer and record the temperature every 10 minutes, and later I will analyze the results. I will record 3 temperatures. One will be the temperature recorded by this cooking thermometer. This is the input hot air temperature, and when it goes to the other side, it will be recorded with this sensor here and this unit here. And also I will record the temperature which is on the display measured by the Sunlu sensor. As you can see, position of the sensors are very close to the filament on the 1 kg spool. So not directly above the hot air, but a little bit closer to the filament. But if you are drying 2 or 3 kg spools, then definitely then the edge of that spool will be exactly above the hot air. The temperature is set to 110 degrees Celsius and the start temperature was 24. Only after 8 minutes it's already 72 degrees Celsius according to its own sensor, 91 and 89. After 20 minutes, according to the oven sensor, 96 degrees Celsius inside. On the hot side it is 118 and on the other side 114 degrees Celsius. Oh, now I notice that even the top cover is deformed now. Looks like this hot air is too much even for this cover. I will check the temperature of the hot air directly later. And I can even feel the hot air leaks out now. This is quite a big gap. With thermal camera we can see that the cover warped and the hot air leaks out. And something similar we can see on the other side, but only in one small corner. Now, even if inside is 122 degrees Celsius, the wall is not hotter than, I don't know, maybe 60 degrees Celsius, so I can touch it without any problems. But this deforming really bothers me. Looks like after 15 minutes the temperature stabilized inside according to its own sensor, 110 degrees Celsius. According to mine, on the hot side it is 131 and on the other side 128 degrees Celsius, but I'm not even measuring exactly above the hot air, but a little bit closer where the spool would be placed. This is the last measuring after 1 hour, 110 degrees Celsius stabilized inside, and according to my sensors 131 and 127 degrees Celsius. Now let's try to measure directly the hot air temperature. I will rotate the sensor. Oh my god, 148 degrees Celsius. No wonder it is deformed. This is too much even for the polycarbonate. I'm not really sure what is the material of this roof. But for the touch it's okay. This double insulation works fine, only this cannot handle these high temperatures. So if you are using a bigger spools, definitely they will be in contact with this high temperature air. Let's analyze this data. The green line is the temperature measured by the Sunlu sensor, and it's stabilized on 110 degrees Celsius after 15 minutes, which is fine. But what I worry about is this yellow line. It measured the air temperature which directly touched the filament on 1 kilogram spool, and here the maximum was 131 degrees Celsius. Significantly higher, especially if I set it to 110 degrees Celsius. But what I really worry about is that the maximal air temperature in this case was 148 degrees Celsius, and if you are using 2 or 3 kilogram spool inside, this air will touch this filament. After 1 hour set to maximum temperature, the power consumption was 0.1 kilowatt hours, which includes the heat up time too. Now let's set the temperature to 90 degrees Celsius and to see what will be the temperature of the air which touched the filament. It reached the 90 degrees Celsius according to its own sensor in only 14 minutes. But the other two temperatures, 110, 106. According to Sunlu sensor, the temperature stabilized after 14 minutes, but I can see that the circulating air stabilized only after half hours. Now this graph is a little bit different. Watching the left side of the curve, it is very similar to previous one when I set the maximal temperature. And this means it starts with the heating on a maximal power, and only when it reaches those 90 degrees Celsius according to its own sensor, it starts turning on and off the heater. But the problem is that that air reached that maximal temperature of 110 degrees Celsius, and only later it stabilized around 103 degrees Celsius. And now let's see what happens if we set the temperature to 70 degrees Celsius. It reached 70 degrees Celsius in a little bit more than 5 minutes, but the temperature of the hot air was 91 degrees Celsius. Looks like the air temperature stabilized, and let's analyze the data. And again in first 5 minutes, until it reached those 70 degrees Celsius according to its own sensor, it operated on a maximal power. And the air reached the temperature of 92 degrees Celsius, and only later it stabilized around 81 or 82 degrees. For the annealing, I inserted the tray, and the sensor will be exactly in the center. Mode 2, 90 degrees Celsius. Only after 10 minutes I started to measure the hot air temperature 2, which is currently 128 degrees Celsius. And the annealing temperature is 102. After 12 minutes it reached 90 degrees Celsius, and probably now the temperature will stabilize. The annealing temperature is 104 degrees Celsius, and the hot air temperature is 130 degrees Celsius. So looks like the annealing temperature stabilized around 102 degrees Celsius, but I need 90, this is what I usually use. So I'm curious if I set to 80 degrees Celsius, if I will get those 90 degrees Celsius approximately. I will open it a little bit to speed up the process. A little jump in the time. Only when I set it to 82 degrees Celsius, then it stabilized, the annealing temperature is 90 degrees Celsius. On this graph, the yellow line is the most important, that's the annealing temperature, measured where our objects will be placed. And this means if we set a 90 degrees Celsius, the stabilized temperature will be approximately 102. And only when I set it to 82 degrees Celsius, the stabilized annealing temperature was 90 degrees Celsius, which I usually use for my objects. One more thing I want to mention here. It looks like that it again starts with the maximal power, only I cannot measure that because now the sensor is on a different location. But this heat up time is too fast. If this is dedicated unit for the annealing too, in that case it would be good to have the possibility to set the heat up time. Slower is better for the annealing, we will have less deformations. I already mentioned that this is a prototype, and one of those things which are fixed in mass production is the firmware, which unfortunately I cannot change on my unit, but Sunlu, if you send me a prototype, then this is the product I can show in a video. And probably one of those things which is fixed is this heat up time, because according to their website they can reach 70 degrees Celsius in half hours. In my case, I could reach this 70 degrees Celsius in a little bit more than 5 minutes. So I believe that this is fixed, but unfortunately I don't know how the final unit looks like. But I highly recommend you to measure this temperature at least once, because you can avoid then to ruin those expensive technical filaments. And all this big work would be much nicer if I could do it with the final product. Now this is useful only to my YouTuber colleagues who also got the prototype. Now beside this, I can see a lot of possibilities for improvement. One of those I already mentioned, rotating of the spool during the drying, especially on these higher temperatures. And also, if this is dedicated for the annealing, it would be good to have the possibility to set the heat up time, because it always starts with the maximal power until it reaches that set temperature. But this is not good for annealing. We need very slow process of the heating. We will have less deformation of the objects. Beside all these problems, I really like this unit because I don't have to use our kitchen oven for the annealing or the drying on these higher temperatures, and this consumes less power compared to our kitchen oven. And I don't know, my wife will be happier. I think the price is quite big. I'm not sure if it will be changing in the near future, but maybe a solution is to use it not only for the drying and annealing, but even for the cooking. I don't know, what's your opinion? Thank you for watching and happy drying. Bye.